Problems in 3 dimensions. Now when we're trying to work out 3 dimensions problems, it's best to sort of look for our right angle triangles. So I better put the word right angle triangles, because when you've got a right angle triangle, you can use the trig rules to find anything you want. Example 16, we have this cuboid. It says find the distance from D to B. Now there's the distance. I just do it in red from D to B. Now if I was to work this one out, that's on the bottom, so that's the floor. So I've got a little right angle here, so I'm going to use that one there. So drawing mine up, I'm going to go, this is for part A, right angle triangle. That is in there. I'm working from D to B out, and that's my C. Now D to C, I know that's 10 centimeters. B to C, that's 8 centimeters, and I'm working that using Pythagoras' theorem. So I've got D to B, all squared, or equal 10 squared plus 8 squared, so I've got 100 plus 64, so that's 164, and therefore DB will equal the square root of 164. Now I can leave it like that, or if I work it out, that is 12.81 centimeters, and that's to 2 decimal places. Then part B says the distance HB. HB is from the top corner to the other side bottom corner, so that's the diagonal. So again, I've got a little right angle. I go down the wall here and across the floor. So I'll draw my little right angle triangle again. H is there, D is there, B is here. HB is what we need to find. H to D is 7. D to B we just worked out, that's the square root of 164. I'm going to leave it like that because again we need to find this distance over here. I'm going to be using Pythagoras' theorem. So I've got H to B squared or equal square root of 164 squared plus 7 squared. So when I work that one out, I'm going to get 213, and therefore HB will equal the square root of 213, which is 14.59 centimeters, and again that's correct at 2 decimal places. So when you use these, you can look around the room. You can do it from there, because when you're in a room, you're actually in a cuboid. It doesn't matter if it's a square cuboid or a rectangular cuboid. You can still look around and try and work out what you're doing. Part C says the magnitude of the angle HB. So H to B, that's where it meets. So that angle there, remember D to B is on the floor, so I've still got a right angle triangle. So I'll just again draw it up. There's my right angle triangle, that's my H there, that's my D there, that's my B here. Okay, and I want to work out that angle between the H and the B, so I've got my tan there. HD I know is 7. DB we worked out, DB was the square root of 164. I'm going to leave it like that and I'll work out the decimals. So I've got tan theta opposite over square root of 164. Inverse tan to find theta. And therefore I get theta is 28.66 degrees. And that's correct to 2 decimal places as well. I better write that in. And D, the magnitude of the angle HBA. So HBA, H, B, and A. Okay, so I'm going to draw that in, HBA. There's my H, there's my B, and there's my A. Now A to B is 10 centimeters, I know that one. HB, we worked out that is the square root of 213, and I want to know that angle in there. So that angle, oops, better put my right angle triangle in. So I've got cos for that, so cos of theta will equal opposite divided by the hypotenuse, and then inverse cos to find the angle. So I've got 46.75 degrees, and that's to 2 decimal places as well. Question 17. The figure shows a pyramid, which is there. The base has sides 6, and the edges that are there are each 10 centimeters long. Part A, find the length of D to B. So D to B is on the base, they're the diagonal of the base. So again, I've got a right angle triangle. So quickly drawing that down. That's D there, that's B there. There's my right angle. I can go to C. So I've got 6 and 6. And I'm using my distance, D to B. So again, I've still got Pythagoras' theorem. 6 squared plus 6 squared. So that means we've got 72, and D to B will equal the square root of 72, which is 8.485, etc. I won't round off because I might need it for something else. Part B, the length of B to E. B to E. Now B to E is half of that. There it is there, B to E. It's half of that. So B to E is just a half from D to B. Now D to B, we worked out what that was. That was the square root of 72. So we've got a half the square root of 72. Now I can work this out. That's a half of 72 is 36 times 2. So square root of 36 is 6 times the square root of 2. And half of 6 is 3 square root of 2. So I can work that out pretty quickly like that. See, the length V to E. Use different colour, V to E. V to E. V to E is that height. So I can use, remember this is going down to the floor, so that will be my triangle there. So part C, I can go from V to E, and then E to B, that's a bad triangle, that's a right angle, so V to E to B, we've already worked out what E to B was. E to B was 3 the square root of 2. V to B is 10, because they show us that on the diagram, all those lengths are 10. So then we've got V to E all squared equals 10 squared minus, because remember we're finding a length here, 3 square root of 2 all squared. So we've got 100 minus 18. So we've got 82. And then therefore V to E, take the square root of 82. And we've got 9.0553. Again, I won't write it all in words. I mean, guys can do that. Part D, the magnitude of the angle VBE. So we want that angle in there. Now, there it is there. We want that angle in there. So we know this length now. This length is the square root of 82. So I can use sine of theta is the opposite. So the square root of 82 divided by the hypotenuse, which is 10. And therefore, when we take the inverse side to work out our angle, we're going to get 64.8959 degrees, which is therefore 64.90 degrees, and that's to 2 decimal places. Example 18 says there's a communications mast. It's erected at the corner A of a rectangular courtyard, ABCD, with side length 60 meters, which is marked already, 45 meters as shown. If the angle of elevation of the top of the mast is 12 degrees, so they show it there, 12 degrees in there, find the height of the mast. So again, to find this height here, I need the triangle from H to A and then to C. So H to A and then to C. So I need to find A to C first. Okay, so let's find A to C. I'll do A to C over here, which is just the bottom. So again, I've got a right angle triangle here. A to C is the diagonal, so I'm going to go to B, and that's A to B is 45, B to C is 60. So using Pythagoras' theorem, AC squared will equal 45 squared plus 60 squared. Therefore, that will equal 5,625, and therefore A to C will equal 75. So now I know A to C is 75. That's good. Oops, A to C is 75. And I also know that this is 12 degrees in here, 12 degrees in there, and I need to find this height here. So I'm going to use, I've got opposite and adjacent, so I'm going to use tan. So I've got tan 12 degrees equals HA divided by 75, and therefore HA will equal 75 times tan 12 degrees, and when I work that out, I get the height of 15.941 meters. Part B, the angle of elevation of the top of the mast from B. So that means from the top of the mast from B, we want that angle there. So we do have a right angle in there, because remember, that's the wall that meets with the ground. So I'll quickly draw that one up. So I've got there, I've got my H that goes down to my A, the right angle. That's going to be B. I need that angle there. That's 45. I worked out H. And I know HA is 15.94. So again, I've got my tan theta equals 15.94, etc., whatever it was, divided by 45. And when I do inverse tan, I get 19.507 degrees.